question is from 2012. It is question 3, so it's not the first question you'll come up against, but it is the third one. Historically, the format of the questions or the content of the questions followed the content of the course. So oftentimes the first question would be, you know, back at that univariate stuff that we did at the beginning of the year, compare the two distributions, that kind of thing. They've since gone away from that, so you could find a hypothesis test question in the first, a normal question towards the end, and then they've gone more towards one type of a question with several parts that could be like all different kinds of questions. So I think that's no different here because you're asked to compare some things and then you're asked to do a hypothesis test as well, right? So it's kind of like a comparison, or it's kind of a mixture of the different units that we've done. The intent was to be able to do two things. One, just compare two distributions. And hopefully you remember the three things. When it says compare distributions, you're going to do what? Shape, center, spread. Woohoo! Okay? So hopefully that's what you did. And then with number 2, we're going to comment on the appropriateness of using a 2-sample T procedure. And it actually told you to do a 2-sample T test in the question, I believe. Is that correct? Oh, but it did say 2-sample T procedure, and all it did was check the conditions. Is really all you had to do. Right. Explain whether they've been met, right? Okay. Okay, sure. Hunter. Okay. The order doesn't matter. Okay?
So that was my question. Like, do they want condition, and then doesn't meet all of them below it, or do they want condition, doesn't meet them?
It doesn't matter.
You guys like state the conditions separately, then explain them, or can you explain them and state them?
It doesn't matter. Basically the same question. Okay? Doesn't matter. As long as you state them and somewhere say they've been met or not been met, then you're good. Okay? You can at the end say they've all been met. That's fine. If they've all been met. I'm not sure they have. I haven't gone through the rubric yet. Or you can do it individually. Either one is fine. And the order doesn't matter as long as they've all been listed. Okay? All right, so let's look at the solution, the ideal solution, and you know I can't do this from the side, so I'm going to go back here on the computer. The household size, we're looking at shape, center, spread. Sammy, thank you. All right, so we're looking at, you can kind of read this whole thing. Let's look at the grading rubric. They really need to identify shape, center, spread. If you look at the median household size, notice they said the word median and then gave a number with it. So when you're talking about center, you need to tell me which measure of center and what that actual number is. With a histogram or a dot plot, you can actually count to find the middle, can't you? Okay, and that's often what they give you. Find the height. I saw Lindsay finding the height of the bars. That's awesome because you can count to figure out where the middle is, right, with the histogram. So median is a great way to be able to do that. The interquartile range, what am I measuring with that? What am I describing with that? Spread, okay. And they did IQR. Are there other kinds of spread? Let's see what the rubric says, okay. And then the shape is at the bottom with the skewed distribution. Okay? By the way, why is median appropriate to use when you have a skewed distribution? Mean would be pulled in one direction, right? So another reason why we're going to use median here. Okay? All right, let's go ahead and let's try and see if it'll scroll down. Okay, it kind of does. All right, so for part B, the 3 conditions that they're looking for is independent random samples, which we mean to say that each of them are individually random and they are not dependent on each other. If they were dependent, would it be a 2-sample T procedure? What would it be? Matched pairs, okay? Just make sure we know that. All right. Number 2, the populations are normally distributed or that both samples were individually large enough, right? And then the population sizes are at least 10 or 20 times the sample sizes, that 10% condition. Okay? All right, so it says that the first one's satisfied because they're independent because they were collected in 2 different years, right? 1950 and 2000. So definitely independent. Question?
The problem states that they're independent as well. Can we just say the problem states that they're not?
I don't know. Let's see what the rubric says. Okay, I don't know. I don't know. Let's see what it says. All right. The second condition is satisfied because the sample size is definitely large enough. 500 is large enough. Therefore, the skewness doesn't matter, right? It meets the nearly normal condition. And then the third one is because 10% of 5,000 is 500, which is bigger than 10, right? Not 10, 10%. 10%. 500 is less than 10% of the entire, is another way to say what they're saying there. Okay? All right, so let's look at the scoring. So they're actually taking these two questions and breaking it up into 4 sections to be able to do the scoring. Okay? Part A has 3 components. Wow. We're looking at comparing them, comparing the centers, variability, and shape. Good grief. What is that? Shape, center, spread. Done. Woohoo, yay. Okay? So that's 3 of the 4 components of this entire question, just in part A. Okay? If it says the words compare distributions, you better be prepared. Shape, center, spread. Okay? It comes up a lot. All right, and then the fourth section was, what was fourth section? Oh, just part B. Okay, fine. So, basically compares the center. It just says E if it compares the center for both distributions. It doesn't say it had to be the median, did it? Let's see if it gives that at the end. Maybe it does. I don't know. Okay? As long as you said one is larger than the other or that they're the same, that would be a comparison. Okay? If you said that the median household size in 1950 is approximately the same as the household size, I don't think they are. One's larger than the other, isn't it? Okay. You would say that the median household size in 1950 was a little bit larger than that in 2000, correct? Is that what you said? Hello? Talk to me. Yes. Devin. That will be marked down, and let me tell you why. Because 3 to 4 is not a measurement of center. You're describing a bar, which would be, let me just finish my thought for a second, because this came up last year. When you are talking about a measure of center and you're graphing on a histogram, you don't say 3 to 4, you say the number in the middle. So if you actually look at where those bar things are, the little marks, they're centered around 4, 5, 6, 7. Right? So you have to actually pick where the bar is. You would actually have to calculate it. So you can't say it's between 3 to 4. Well, the good thing that AP usually does is if you look at the 2 graphs, aren't the scales exactly the same? Okay? So honestly, you could draw a line in approximately where you think the middle of those 2 histograms are and know that the one that is on the top is further to the right. And that, honestly, is enough to compare the centers. It can be that basic, Devin. But do me a favor, that wording of between 3 to 4 and between 5 to 6, I can see them marking you off for that. Okay? Okay, let's keep going. Then they ask you to compare the variability, and they just mean a measure of spread. Did anybody use something other than IQR, or they just say the words, looks like it's more variable? What'd you say, Devin? That's perfect, and that's good enough. That's good enough, honestly. Has more variability, is more spread out, done. That would give you an E.
I just said it's a range.
Be careful with range. Remember, range is like the least wanted. You don't want to use range that often. I would just literally just say that the data is more spread out. I don't think they would count off. Because you could have an outlier. You know what I mean? That would affect the range. So just be real careful with using that. Honestly, spread further from the center would be a better way to say it. Okay, that's fine though. You don't have to use an IQR value here. All right, and then section 3, it talks about the shapes. Notice that you had to do 2 things. You had to correctly identify the shapes of both distributions. Oh, they changed again. I had this nail color that changes colors on me, and it turns dark and light, and it's freaking me out. Every time I look at it, it's different. Anyway, okay. It's essentially correct if it includes context related to the variable of interest. Anyone just talk about the shape without saying the household size and didn't use the context? If you did that, it's a P for section 3. Because it says partially correct if you identified the shapes, but does not include context related to the variable of interest, which is the household size. So they want you to say something along the lines of, the distribution in 1950 for household size is, right. They want you to use that variable. Okay? So I have tried to stress this as much as I can, context, 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 all year. And that's an example of where you would be docked if you didn't do it.
And only counted that for...
They only counted the context for number 3, for section 3. No, not for center. I think it was just E or I. You either had it or you didn't. You either compared them or you didn't. Hang on. Yeah. Oh, variable. Hang on, center. E or I. No P. It'd be I if you didn't compare the center. If you said one was O for you, yeah, I mean, I think that would be, yours would be a question that I would, if I got it at my table, I'd bring it up to my question leader and be like, what do I do? And they would take it from there, and they would take it up to the next person, and your answer would have gone up the chain. I can just tell because of the way you wrote it. So just try to be as concrete as you can. Okay? All right, let's keep going. Come on, baby. Let's look at what section 4 is on. Section 4 is essentially correct if you state the 2 conditions. It only wants 2. Interesting. Data come from independent random samples, and the normality has been met because of the sample size is large enough. So you really you didn't have to do the 10% because they were independent, I guess. Yes. I'd have to look at it. I don't have enough time right now. I will say 3.5s tend to not go up to 4s. Typically, and Hunter's got a good point. Typically, this is typically, obviously there's exceptions. Typically, 1.5s, 0.5s, and 2.5s. Actually, I'd say usually on the lower end of the 0.5s, they will round up. On the upper end, they tend to round down. Typically. So typically, that would be a 3. And is it because of the context? That's the only thing you missed? Oh, I don't know then. I just don't know. I'd have to be in that situation. It probably wouldn't have been, I mean, because they spot check us as graders, so if I was like, gosh, the only thing they missed on this question was context, I might have gone ahead and moved up to a 4, but then I probably would have been overridden. So, yes. That's okay in this question. They're just looking for it at one time.
Oh, wait, did I use it in the other?
Then you're fine.
Oh.
Then it should be a 5. And do you understand Brian's question? If you stated context somewhere, I think you're okay. As long as you wrote somewhere household items or household item size, you should be okay because that is context. Yeah, as long as you did somewhere, I believe that's okay. All right? Now, again, it depends on how they graded it and, whatever. I wasn't there, but that's how I would have graded it. No, somewhere in sections 1 through 3, somewhere, if you wrote context, I think you would have gotten that, met that condition, that thing. Okay, so then you got a 4. Okay? How do we feel about that question? Totally doable, right? Totally doable. Notice how this one mentions a hypothesis test, but doesn't make you do one from beginning to end. Oftentimes that happens, okay, where they'll just do little pieces of a hypothesis test. They'll ask you to interpret a p-value. They'll ask you to state conditions or check them. They'll ask you to do pieces. Occasionally they'll ask you to do one from beginning to end, like the question we did before, but not all the time. Okay? Yes, ma'am.
So when I ask you to do, like, if it's just a p-value, should we check the conditions just in case, even if it isn't?
Often it will say you can assume the conditions have been met. If it says that, you know you don't have to. If it doesn't say that and you have time, do it. okay? But it's a time issue, right? Sometimes you have the time. Like on this question, it did not take most of you 10 minutes, and it shouldn't have. They do try to put some of the shorter questions in with some of the bigger questions. Knowing that, that's why the 10-minute thing is an average, okay? How do we feel? 2 easy ones in a row, right? Woohoo! How many of us got 4s? 2 people? 3.5, you're got a 4. Raise up. 3.5. How many got 3.5s or 4s? Yay! All right, that's good. A lot more than normal. Yes, Devin. Section 4 is, if you look at the top, it was just question B, part B. Remember, part A was 1, 2, and 3, and section 4 was question B? Yes. Question A was sections 1, 2, and 3, shape, center, spread. They typically, every time for every FRQ, they divide it up into sections to give you an EP or an I. And typically, they try to do 4 sections so that they're half a point, or they're a point each. Okay? Or every E is a point. That's typically what they do. All right. Are we good? All right, go ahead and put this one away for us. We'll look at another one later on. And we are, like I promised, because we only got through confidence intervals last time with 2SampleTtest, we're going to go ahead and do the full hypothesis test as well, okay? And then after we do this one together, I'm going to give you guys some problems that are a mixture of all the tests we've done so far, okay? And so it's going to be, maybe you have to do 1 sample proportion. Maybe it's a 2 sample proportion. Maybe it's a 1 sample t-test. Maybe it's a matched pairs t-test. Maybe it's a 2 sample t-test. You got to know when to use what. Okay? And what I'm going to do is that's going to be your homework assignment. It's going to be a mixed bag of some things. And then next class on Tuesday, you're going to have a short, I think I'm going to make it 10 questions, multiple choice quiz on the different types of tests.
So you chose the problem and then you have like 1 sample.
Well, that might be one of the questions. It might be like identify which test to use. That might be one of the situations, but it's not going to be all of them. I might ask you some specific questions about any of those procedures, okay? So it's just a matter of, you know, I'm not going to ask you what the formula is or anything like that, but I might ask you to identify the hypotheses for any of those. I might ask you to find the confidence interval using your calculator. It will be multiple choice, so by all means use your calculator. I might ask you about conditions, I mean any of those things. Okay, so it'll be a short, it'll be 20 points, so each multiple choice question will count 2 points. All right, and it's just going to be a quiz that we're going to have. Fair enough? You okay, Kyle?
Yeah. She was just saying you're almost done, and I was like, oh,
I know, you're getting there. We only have 4 more tests to go. Chi-squared's not bad, though.
Calculator tests or tests?
No, tests like hypotheses tests. Oh, not like tests in class. We're going to do 1 test this quarter because remember your SAT counts, the investigative test counts as 80 points. Then you have the quiz, so that's 100 points. Then you're going to have a real test. Then you have that test, your AP exam. Then after the exam, it's your project.
that's it?
That's our
After I
final,
came,
right?
That one actually.
But you're going to have a little bit of, hang on one second. You're going to have some little things as we go along that will count as grades. Like you'll have to turn in, you know, your introduction, and that'll count as a grade. You'll have to turn in this, and it'll count as a grade, that kind of thing. We'll talk more about that after the exam. Okay? Yes. Oh, I'm sorry. You had a question first.
Yeah. Is the practice exam going to count for anything?
I'm tempted to give you extra credit for going. Okay, I think I should, because if you can take time out of your schedule to go to the practice exam, I think I should give you extra credit. So I will. So bring me the test back as proof that you went. How's that? Okay? Good. Question, Hunter? No. I just said that that's another test that you have. Now, you won't get those results until July. Have some confidence, Sammy. Goodness. All right, guys. Let's complete a hypothesis test. Let's use the same information that we talked about. Oh, this is not it. Hang on. This is that talking counting thing that was driving me crazy. Hang on. But remember how, this is the one I wanted to do. Remember, this is the one we did last time? Because like, what's the difference between talking and counting? That was a matched pairs t-test, wasn't it? Anyway. All right, so let's do this one. Hey, come on. You can do it. I know, not even 51 minutes. Come on. All right, so we did a 90% confidence interval before. Remind Tanner what we found last class. Deja, what did we find in our confidence interval last class with this? Does inner city cost more? Does their food cost more than suburbans? Suburbans. That's a car. Suburbanites. It did, didn't it? Remember our confidence interval was all negative? Do you remember that from last class? And so we didn't capture 0, so there was some statistically significant evidence to suggest one thing, that inner city people had to spend more on their food than people who lived in the suburbs. So we've already kind of answered the question, but let's take the same information and complete a hypothesis test. What step for us has already been done, not in terms of the steps of the hypothesis test, but the way that the information is presented here, that maybe might not always be given to us? Tanner. Right. The mean, standard deviation, and sample size were just kind of given to us in a table. Sometimes we're given just 2 raw data sets where we'd have to complete that, kind of like you had to do on your SAT investigative task, right? Okay. So we've at least got that. It's a starting point. Woohoo! So what we're going to do is we're going to actually compute a hypothesis test from beginning to end. So what should we always do when we're asked to do a hypothesis test from the very beginning? State the test first. Remember how on the rubric for the AP exam when we had to do the test, they took off if you didn't state the test? Let's do that. All right? So what kind of test am I doing here? How many samples do I have? 2. Are they matched? They're independent, so I'm looking at a 2-sample t-test because I'm dealing with means, right? Okay, so we're going to name that 2-sample t-test. That was a lot to pick up. All right, I'm going to go ahead and do my null and alternative hypotheses. And we probably should, I don't think I've told you how to list those, but we can probably infer what we need to do. What would you assume our null hypothesis to be? Remember, the context is going to be a situation, so what are we looking at here? Kyle? You can do that. The difference is not 0, or they equal each other. It would equal 0, not equal 0. It would equal 0, okay? The difference would be 0, or they would equal each other, either one. Rather than use mu1 and mu2, if you wanted to do 1 and 2, as long as you told me that 1 was suburban and 2 was inner city, I'm cool with that, okay? But I'm going to go ahead and use S and IC just so that I know the context. Is that okay? All right. So I'm going to say that mu of the suburban is equal to the mu of the inner city. And if we look at, we have to look at the question wording to be able to decide how we're going to write our alternative hypothesis. And it doesn't really say, does it? It doesn't really say anything about, because I kind of made this up, right? So let me tell you, so rather than we did this last time, we're going to go ahead and do a hypothesis test to answer the question, do inner city people pay more for groceries No? Do inner city people pay more for groceries than suburbanites? I think I just made up that word, by the way. It's totally a word, right? That Miss Mackert made up. It's a Mackertism. Nice. It doesn't change the mu, because we're still dealing with the means. What it does, by proposing that question, you kind of have to know what you're looking for before you do the hypothesis. That defines your alternative. That tells me what alternative hypothesis we should be doing. Okay? And so which one should we be doing? Oh, I'm sorry, question first. Isaiah. Yes. Yes. If there's not anything clearly defining a direction one way or the other, is there a difference between? Yes, you would do not equal to.
It's a word.
Is it really?
Serious, yeah.
Yeah, I thought I made it up. Oh, man. All right.
Sorry to ruin it.
Suburbanites. I thought I made it up. I'm going to pretend like I made it up anyway. All right, so here we go. So we're going to say, what am I looking at here if I'm comparing these two according to that question that I just posed? So I'd be a less than in the way I've written it here, correct? Inner city is more, right? A less than the way I've written it. Okay. And again, if you're doing this on an actual exam, you should probably write a sentence or two of context for each of these. Tanner, I don't see a pencil. Ha ha ha! You're hiding it from me. Secret pencil. Okay. So what do we do from here? We've written the name of the test. Thank you. Check our conditions. Okay. And according to the last AP exam question, this one that we just did that was 2SampleT procedures, what are the two conditions they're looking for? Independently random samples and normal. Okay, so let's look at those. So, what do you think? Let's go back to let's look at the independent sample things. Are they two independent samples, and were they conducted randomly? Well, we can assume independence because you're either living in the inner city or the suburbs, right? It's not like Manassas is like inner city, you know what I'm saying? We're the suburbs. So it's one of the two. Would you agree? You're in one or the other. So we can say that. What about the random condition though? Does it say that in this problem? It doesn't say. But if you remember what I just crossed out, right? Doesn't it kind of say that here? So we should go ahead and just use that information. Do you agree? Because if I'm not given the actual, well, actually, I could say that they were representative samples. We would hope that they would be representative, and we could go from that perspective, and that would be fine. Why don't I care about normal? Why do they meet the normal condition without having the raw data, without having a shape or a graph? Why do they meet it? The sample sizes are both greater than 30. Awesome. Come on. Okay, here we go. So we're going to say that they are independent random samples, or we'll say independent representative samples. And we should say both are, okay? Because we should be discussing them individually, okay? Both the suburban sample and the inner city sample are independent of each other and representative of their respective populations. Two, we're going to say that because n equals 35, and what was it, 45 for the other one, I think, are both large enough, are both greater than 30, and therefore we'll say large enough to meet the nearly normal condition. Okay? So we have done what so far? Let's think of in terms of EP or I. How far do you think we've gotten so far? Well, we've named the test, we've stated the conditions, and we've stated the hypotheses. Probably gotten maybe half credit? Maybe? I don't know. We'll see. Let's keep going. Okay? So what's the next thing I need to do? Am I going to pool? Am I going to go swimming? No. Because? Means. When do we pool? Proportions. Okay? We're not going to pool with means unless we know that the individual population standard deviations are exactly the same, which we will never know. Okay? So, what do we do? How do I do it? What do I do? Brian? It wouldn't matter because you could just say both samples are large enough to meet the nearly normal condition is fine. The sentence after that kind of clarifies it. Shh. The 10% condition is assumed because 10% was the independence one, right? So because they're independent samples, you don't have to do it with there. You could go ahead and do the 10% condition, though. That would be okay. Okay? Yes. Yeah, we'll find the standard error. And can we do that in the same step as the test statistic? Because it's all kind of together, right? So if I wanted to say the test statistic, we could do the standard error at the bottom. Is that good with you? All right. Oh, hang on. I don't want to give it away. All right. So, what? Yeah. These are the standard deviations of the samples, the sample standard deviation. So we are finding a standard error. That is true. Is that what you're asking? Okay. Yes. True. That's what you're saying, not asking. Yes. All right. So what is the test statistic? And please only use your formula sheet right now, not the extra one that has all the conditions on it. But if I wanted to look at the formula sheet, let's find the test statistic on there. Is it on there? Is the standard deviation on there? What is on there that will help me here? Then do it. Tell me. What do I put on the top? Well, give me the bottom then. Yes, you may. No. All over or separate like that? Okay, like that? All right, and then 1.23 squared? I got you. Oh. Look at your formula sheet. Is it 45 and 35, right? Yes. Come on. You're on fire today. All right, so we have to be careful of the direction that I'm subtracting, right? We have to be careful and just make sure we note that. I think we did in our confidence interval, we did suburban minus inner city, right? So we'll continue with that. So 3652 and 3940. I'm not going to remember that. 3652 minus 3940. Yeah, I did remember it. Good enough? Yes, question.
So right now, is there, I guess the order doesn't matter of these stuff, as long as you keep it like.
Because I did suburban and then inner city up in my hypotheses, that's the order I'm going to put them in here. The order your hypotheses go should be the same order you put them here. Be consistent. Okay? Tanner. Let me see your pencil, your secret stash. There it is. Okay, here we go. So I can actually, from here, just put in my calculator and get the answer. I'm cool with that. Okay? It'll give you a test statistic at this point. Let's go ahead and just do that. I think I might hopefully still have it in here. Didn't we do it on the calculator before? I don't know if we did. We're doing a 2-sample t-test. Yay, look at that. That's so exciting. It's still there. All right, so the stats are still there, except for the hypotheses is going to be which one? The not equals, the less than, or the greater than? The less than. So we're going to make sure we put that there. And we're not pooling. We only pool with proportions. PP. Don't pee in the pool. All right, calculate. And here we go. So I got a test statistic of negative 10.876. Is that unusual? It's not like a z-score, so it's not like a -3, and anything outside of -3 is unusual. You can't really tell that with the t because it has to do with the different degree of freedoms and stuff like that. So that's not really an indicator like it would be for a z-score. But it does seem like it's awful far to the left. All right, so we're going to draw it. What goes in the middle? Oh, I wasn't supposed to tell you. What goes in the middle?
0.
Okay. Yes, question? Not yet. The p-value is going to reaffirm that. Okay? Because we don't know if it's negative enough. Right? Because I'm not sure. Because it depends on the size of the populations and that kind of thing. That's why the t-score is not really an indicator right away. It just depends. To find our p-value.
Oh, yeah.
Okay? So negative 10.876, 0, we're looking for a less than situation. What am I doing by drawing this? What am I telling my AP reader what I'm doing here? I'm showing direction, I'm showing bounds, I'm showing all those things, right? All right? So how do I find, well, I'm sorry, what's next? Normal CDF, okay? I'm going to go ahead and find my p-value. Oh, yeah, not normal, t, right? I just was going along with what you said. Exactly right. We're looking at t's. It's not normal. It's t CDF because we're looking at t distributions. We're going to have the negative E99 as the left bound. I'm going to write it underneath because I'm going to run into over here. Negative 10.876 is the right bound. Come on. And what is the degree of freedom? Well, look at what the calculator gave me when I did the test. Which one would we have probably used? The largest sample size minus 1, right? So 44. Why did the calculator give me something different? It has some crazy formula, right, that we're not going to ever ask to do, but it's going to give you a much more specific degree of freedom. And that's okay. Your p-value won't be that different, okay? But that's a more precise one to use if you wanted to use it. And then we could go ahead and say that your p-value was, approximately 0, right? That's a p-value? Huh? Yeah. Okay. Doesn't happen very often, but in this case it's happening, right? So what is that, and does that support what we found with the confidence interval as well? Yeah, because in the confidence interval we did not capture 0. Everything was off to one side. So we said that the who paid more, the inner city paid more. So with this, let's go ahead and finish off the test. What are we going to do with that really, really small p-value? We're going to reject or fail to reject. Reject that bad boy. I have a funny thing to show you with that, by the way. Remind me by the end of class to show you the picture I have for you. Reject the null. And then what are we going to say? What's our conclusion in context? Okay. Sure, we can say that this is less than 0.05. That's fine. Therefore, we have statistics. I would even go, because that's a really small p-value, right? I would even go as far as to say we have statistically significant evidence, right? Because what if it was just like 0.049? Well, that's evidence, but it ain't that strong. You know what I'm saying? All right, I just said the word ain't out loud. I'm embarrassed. Okay. So we would say that we have statistically significant evidence. We have strong evidence, would be a short way to say that. That suggests, don't you love all this vagueness? We have evidence that suggests that inner city pays more, right? That this is true, because we rejected that null, okay? That inner city people pay more than suburbanites. How do we feel? Question. Zero is not captured only in a confidence interval. So because we didn't do a confidence interval here, we don't want to mention that here. Well, because there's no interval to show, it wouldn't make sense. It doesn't go together, really. If you did the interval first and said that, yes, then that would be fine. Well, if you did both, and as long as the 0 wasn't captured, went with the confidence interval, then that's fine. But a 0 not being captured, there's nothing to capture. There's nothing to capture here. There's no interval to capture. Okay? How do we feel about that? Not too bad, right? All right. Picture is important. Conclusion and context is important. Our test statistic is important. We graphed it. We feel good. All right. I want to give you some time. We have about 30 minutes, which is great, to work on some of these mixed bag types of problems. And I'm going to give you, here's all of the tests that could possibly, and it's not only tests. I think I have some intervals thrown in there too. So it could be a test or an interval. We'll call them procedures, whether it be 2 sample, 1 sample, whatever. So you could have a 1 proportion something. You could have a 2 proportion something. And these are z-tests or z-intervals, depending on whether it's an interval or a test. I'm sorry, a test or, yeah, interval or test. So 1 proportion, 2 proportion. You could have a 1 sample t-test. You could have a 2 sample t-test or interval. And this is a test or interval. These are all test or interval, okay? Yes, because proportions is always z. Unless you know the population standard deviations are exactly the same, then you can use, whatever. 2 sample t-test as well, or I'll just say t, whatever. And then what's the other one that we can do? The matched pairs. Okay? Now, matched pairs, I have seen on previous AP exams where they do an experimental design question where you're actually doing a before and after design. You're actually designing it that way. And then they'll throw in like part C or D of the question being a matched pairs t-test. So they kind of go together, just so you know. All right? All right, so let me go ahead and give you those problems. It is out of the textbook. If you will throw on the lights for us, that would be awesome. It is going to be at the end in this review in your book after chapter 25. I'm going to have you do page 450. It starts on page 459, by the way. And don't forget, you have a quiz next class, right? So a short quiz. 10 questions on all of this, okay? All right, I'm going to have you do questions 6, 7, 8, 9. Look at that. It's kind of going in order. Woo-hoo. I'm going to skip 10, skip 11, 13, and I'm looking for one other one. Yes, dear.
What is that right?
Oh, no, not at all. It's 459 in my other book. No, totally not. Sorry, it starts on page 597. Sorry, I was looking out of my answer key book. I'm trying to find, thank you for bringing that up. I need one other one. Oh, I need 33. Okay. There you go. It's all mixed together. What are we going to do with each one? Okay? Fair enough? All right, I'm going to give you the rest of class to work on that. And you can grab a book if you need to grab a book off the shelf. That's totally fine. And it'll be due next class before the quiz, okay?
Yeah.